Hello friends, welcome to our channel. Let's have a look at problem 3446, sort matrix by diagonals. So here we are given the n by n matrix. So what we want to do is to solve the matrix. So for the lower diagonal matrix, so we're going to sort in large to small. In other words, decreasingly. Like if you look at diagonal 186 and the sub-diagonal 95, and further 4, right? It's going to be decreasing. And then the remaining above the leading diagonal is going to sort it from small to large. In other words, increasing. So you can digest the requirement in example 1. So basically here, n is in between 1 and 10. Actually, at most, we are going to have 100 cells. And here, the grid length and the number of rows and number of columns are the same, right? So with that said, I guess we are ready to start the coding. So the key thing is that how do we identify the diagonal elements? So by diagonal, I mean, so the leading diagonals, the ones parallel to the leading diagonal above and below, right? First, let's so here I'm going to use m and n. So length, grid, and length grid 0 because we want to solve a general question. So if m and n are not the same, so still we can solve this. So m, so here actually equals m. So here first I want to get the diagonal equations. So if you look at the leading diagonal with, say, in example 1, 1, 8, and 6, so what you get is I minus j equals 0. So they are the same, right? So this is the leading one. So then if you want to go below, so for example, if you look at 9, 5, you are going to see I is incrementing by 1. So, but j does not increment. So actually this will correspond to I minus j equals 1. And then you further go to 4. So still I increment by 1, but j does not increase. So you're going to have 2. So in general, what you get is actually up to m minus 1. So this is the one on the leading diagonal and below. So if you look at the upper ones, so you can see you use the 1, 8, 6 line as a reference. Then if you go to move towards the right, so I does not change, but j incremented by 1. So there you are going to get -1, -2, then actually up to negative m minus 1. So this is the above the leading diagonal. So once you realize these relations, then writing the code should be rather straightforward. So here, basically for D, this is the difference of I and j in range. So because the smallest one, so here I'm going to do from negative m minus 1, then up to m, right? From the smallest to largest. So first, if D is greater than or equal to 0, we are considering those diagonals, right? So for those diagonals, so I'm going to sort it in a the increasing order. Then I'm going to use pop operation. Notice that sort in increasing order and using pop. So this using pop will be O1 operation. That's why I choose this. So let me first get a temp. So then I get the elements in each of the diagonal. You can think of 1, 8, 6, 9, 5, right? Then for I in range, so for the leading diagonal, it will be from 0 to m minus 1. But if you look at this one, it's from 1 to m minus 1. So actually it's going to be from D to m. So because here we end at m, we end at m minus 1, right? That's why we write m here. So then we are going to do temp append the current element in grid I, and because I and j, the difference is d, so I'm going to use I minus d. That will be j, right? So then after we get this information, I'm going to do sort. So notice that for this diagonals, so we're going to make it from large to small. So here I'm sorting from small to large. The reason is that I'm going to use I need this for loop. I want to assign those elements in the grid. So grid I and I minus d is going to be temp pop, right? So because this for loop and this for loop, in the first for loop we have this number m minus d plus 1 append. So here we are going to have m minus d plus 1, m minus d, not plus 1, m minus d pop operations, right? So this is the one part. Another part is that but here I'm going to sort in decreasing. Then I'm going to use pop, right? So here again we have a temp, but this time, so we're going to iterate over g for g in range, so from negative d to n, right? So you can see here, so d is negative in this case. For example, here is -1. So I'm going to from 1 end at the last one, right? So in this case, for g, so I'm going to do temp append. So here we are doing grid g, right? So because I equals g plus d, so let's write like this. Then what we are going to do is temp sort. So here I'm going to do reverse. So then in this case we can do the same thing. Then basically for g in this one, because here we are sorting in from large to small. Then if we do pop, we are going to small from small to large, right? So grid g plus d g. Will be temp pop. So then I just need to return the grid. So here I'm doing some in place operations. So now let's do a quick check. Yeah, it passes the 3 test cases. Now let's look at the generic case. Yeah, it passes all the cases. So again, I want to emphasize that in this problem, it assumes it's a square. So we have m and n equal. But if not, m and n does not equal, so this is the distinction, right? So with that said, I guess that's about it for the current video. Thank you for watching.